Welcome to Helpyout. Let's discuss WBJEE math questions of 2018. We know sine is increasing function in the first quadrant because for sine 0 we get 0 and for sine 90 we get 1. So it is increasing from 0 to 1. So what happens when we compare it with 30? Sine 30 will be less than sine 31 because sine is increasing function and we know sine 30 is half, that means 0.5. So sine 31 is greater than 0.5, and where is greater than? Here is greater than sign, so option A is true. f1x is given, that is e to the power x. f2x is e to the power f1x, that means e to the power x goes here. See, here is 2 and we got 2 e's. Here was 1 and we had 1 e. For f3x similarly it will be e to the power e to the power e to the power x. 3 is here, so number of e's is 3. If we differentiate that, then first derivative of f1x is e to the power x. If we differentiate f2x, then for e to the, let this be z. We know derivative of e to the power z is e to the power z. So e to the power x will come back, and then we have to differentiate this for chain rule. That will be e to the power x again. For this part, e to the power x will come back because this is z part. This part is z and z is c, f2x. We have to derivative f2 again, so like this, and this will be, we had this here, so it will be e to the power x times e to the power x times e to the power x. So see, every time we do this, here we got f1x back, here we had f2x times f1x, for this we got f3x times f2x times f1x. So option C is true using mathematical induction. Since this part is under radical, so it should be greater than 0. So 1 minus absolute value of x by 2 minus absolute value of x should be greater than equals to 0. And when it is greater than 0, so both of them should be positive or both of them should be negative. Two cases. For the first case, 1 minus absolute value of x is greater than 0, greater than equals to 0, or not, or actually and here 2 minus absolute value of x will be strictly greater than 0 because it can't be equal to 0, denominator is never 0. From here we get absolute value of x is less than equals to 1, and here we get absolute value of x is less than 2. Combining them we get this part because this one is smaller, so x is between 1 to minus 1. And for another part, when both are less than 0, so 1 minus absolute value of x is less than equals to 0, and 2 minus absolute value of x strictly less than 0. Same way it is not equals to 0, so absolute value of x is greater than equals to 1 and absolute value of x is greater than 2. So which one is smaller, greater than 1 or greater than 2? See, if we take greater than 1, then this part minus 1 to 1, and we have to go outside of this part. And if it is absolute value of x is greater than 2, then here will, sorry, this should be plus 1, and here plus 2, and here is minus 2. So this part should go from 2, outside of 2 and outside of minus 2 here. So this part is smaller from here and from here. So we will consider this thing. This means minus infinity to minus 2 union 2 to infinity, and from here we had minus 1 to 1. So this becomes option B. For this question, you need a trick. You have to assume a new function hx equals to e to the power kx times fx, where fx is same as this fx and k is same constant here. So hx, for hx we get ha equals to e to the power ka times fa, and fa was 0, so ha equals to 0. Same way hb will be equals to 0 because fb will be equals to 0. So ha equals to hb, and hx function is differentiable function because fx is differentiable and e to the power kx is differentiable too. So this follows Rolle's theorem. Using Rolle's theorem, we will get h dashed c equals to 0 for some c belongs to a to b in interval a to b. So what is h dashed c? Let's find h dashed x first. So we differentiate e to the power kx. E to the power kx gives e to the power kx times k because of chain rule, and then fx is with it, and we are using product rule. So now e to the power kx will be fixed and we will differentiate fx. So we get f dashed x. This is h dashed x. So h dashed c will be taking the e to the power kc common and plugging x equals to c. So this will give k times fc plus f dashed c equals to 0 because h dash c was 0. E to the power kc cannot be 0, so we get this part equals to 0. See, this is jx. In fact, this is jc, I mean. So we got jc equals to 0 for some c belongs to in interval a to b. So option C is correct. For this question, we are going to simplify this part first. So for this part, we get f1 minus f of 1 minus h, because I took minus common here because I am trying to use the definition of differentiation. So see here, I got f x minus f of x minus h, where x equals to 1, and here we need h below to make it f dashed 1. And so because we divided by h here, we have to keep another h here, and this part will give h times h square plus 3. H cancels, so this part is minus f dashed 1, and this part is limit h tends to 0 by h square plus 3. So we need to find f dashed 1. So f dashed x is, the 10 goes here, let's find f dashed x here. F dashed x equals to 30 x to the power 9 minus 56 x to the power 7, then plus 30 x to the power 5, then minus 63 x square plus 6x. I hope I got them all. 1 2 3 4 5, 1 2 3 4 5, yes, and 7 will give 0, and we are plugging 1 in this thing, so we get 30 minus 56 plus 30 minus 63 plus 6, and for h equals to 0 this becomes 1/3, and then we get 30 plus 30 is 60, 60 minus 56 is 4, 4 plus 6 is 10, 10 minus 63 is minus 53, and we had another minus here, so this will be plus, so 53/3. This is option C. For this one, we have to use conclusion from question number 4. In question number 4, we had f dash c plus k times fc equals to 0 for some c belongs to interval a to b. Here we have to assume k equals to -1 because that f dash c and fc are on different sides. So we get f dash c minus fc equals to 0 or f dash c equals to fc for some c belongs to interval a to b. So this is option A. For at least 1 point C we got this condition. Or if you don't know the conclusion from question number 4, then you have to use hx equals to e to the power minus x times fx. Now see, if we find ha, that will be e to the power minus a times fa, and fa was already 0, so 0 here, and sorry, my mistake, hb will be 0 too because fb will be 0 again. So we got ha equals to hb, and x is differentiable because e to the power minus x is differentiable, and so is fx. It was given here, fx differentiable. So h follows Rolle's theorem, and using Rolle's theorem we get h dash c equals to 0 for some c belongs to interval a to b. And what is h dash c? H dash x is minus e to the power x times f dash x times minus e to the power minus x times fx equals to 0. This was h dash x. So h dash c will be e to the power, sorry, here it had to be plus, my mistake, e to the power minus, here e to the power minus c goes outside, so it becomes f dash c minus fc equals to 0. E to the power minus c cannot be 0, so f dash c minus fc equals to 0, which leads to f dash c equals to fc. And for this part again I used product rule here. Here e to the power minus x was fixed and fx was differentiated here, and here fx was fixed and e to the power minus x was differentiated here. For chain rule, that minus came down for that minus x. I hope you understood. In this question given f0 equals to f1 and f is differentiable. In fact, it is twice differentiable. So we get f0 equals to f1 and f is differentiable, means it follows Rolle's theorem, and using Rolle's theorem we will get f dash k equals to 0 for some k belongs to interval 0 to 1. Now again we have f dash 0 equals to 0. So we get f dash 0 equals to f dash k, and f was twice differentiable, that means f dash is differentiable. And when f dash 0 equals to f dash k, and f dash is also differentiable, so we can apply Rolle's theorem on this again. So what do we get? We get f double dashed c equals to 0 for some c belongs to interval 0 to k, and this 0 to k belongs to real number, so we will get option B to be true. C belongs to real number set. For this question, we will simplify this inside first. We are going to divide by cos square x. So this will be integration e to the power sin x times x cos x minus, and here is sin x by cos square x. If we make two parts of cos square x, then sin x by cos x will be tan x, and another 1 by cos x, that will be sec x. This is times. Here we need a trick actually. See, if we use e to the sin x is common here, and we need to write extra minus 1 here and plus 1 here, and here was tan x times sec x and dx, of course. If we make two parts of this part one part and this is another part. For the first part we get e to the power sin x, and taking cos x common from this first part, so this will become x minus sec x, and for this another part we get e to the power sin x times 1 minus tan x times sec x dx. And here notice this is differentiation of e to the power sin x, because if we differentiate e to the power sin x, then e to the power sin x will come, and for sin x we will get cos x because of chain rule. And if we differentiate x minus sec x, then we get x gives 1 when differentiated, and sec x gives sec x times tan x or tan x times sec x. So this is basically differentiation of e to the power sin x times x minus sec x times dx. Sorry, not dx. Here I have used d already. So integration and differentiation cancels, and we end up with e to the power sin x times x minus sec x plus c. So fx is this one, option B. That process was very tricky. If we can't find out, we have to take the 1 extra, minus 1 and plus 1, then there is no way we can solve it in time. So let's be little intuitive. See, we got here tan x times sec x. So which function gives that derivative? Of course, tan gives sec square x. Option C and D had tan x. So we can cancel option C and D already. And if we take, let A is true, so that fx, let's write hx equals to e to the power sin x times fx, which is sec x minus x, and we will try to differentiate this thing h dashed x. We are basically trying to find the inside function, this function, or in fact this function we can say. E to the power sin x gives e to the power sin x times cos x, and this will be fixed because we are using product rule. First we have differentiated this part, and now this part will be fixed, e to the power sin x, and we have to differentiate the another part. This gives sec x times tan x minus 1. E to the power sin x goes outside, So this become cos x times sec x is 1, then minus x times cos x plus sec x times tan x minus 1. 1 cancels. Here see, we got minus with x cos x and plus with sec x tan x. So we had to take the minus outside. If we have switched this side sign here, this would have made this x minus sec x. That would be option B. Using this process also you could solve it in time. For this question, see, we don't know fx. We have to find fx. So for the LHS part, we cannot find the integration. But for this part, RHS, without knowing fx, we can still find derivative, because we can write it as f dash x. So let's find derivative of right hand side. What will it be? That will be, this part is constant, 1 by 2 b square minus a square times log of fx will give 1 by fx, and because of chain rule we will get f dash x, and c gives 0. So let's arrange it little bit. F dash x divided by 2 b square minus a square times fx. This part should be equals to this part, because the integration of this thing is this, so differentiation of this should be this. Writing it equals to fx sin x times cos x. Now see, if we cross multiply by this here, and I am going to write fx equals to y in the next step, and f dash x is dy by dx. So dy by dx equals to, you will see why I wrote this thing. Fx times fx is f square x, that is y square, and 2 times b square minus a square times sin x. Okay, I am going to write it here. 2 times b square minus a square times sin x times cos x. And here we got 2 times sin x times cos x. We can write it as sin 2x. Writing this b square minus a square here, y square times sin 2x. Now see, we got a differential equation, and we can make two parts out of this. Let's write it, dy by y square equals to dx. I'm going to just put b square minus a square times sin 2x times dx here, and then we can find integration. Okay, I need more space, just a moment. So if we integrate this part gives minus 1 by y, and this part, this was constant, so this is easy. B square minus a square goes outside, and for sin 2x we get, sin is, the integration of sin is minus cos, right? So this will be cos 2x, and we had another 2 here, because of that we have to divide by 2. This we got, and using plus some constant here, then this is not so much important though. From both sides I can cancel this negative, and y becomes, let's just delete the k from here. So y equals to 2 divided by b square minus a square divided by cos 2x, or I can write it as 2 by b square minus a square, and this become sec 2x. So let's see which option matched. Yeah, here they had cos 2x, actually option C matched. We didn't need that part so much. Let's just delete that. Answer is this one, which was option C. 2 by b square minus a square by cos 2x. For this question, we will start with n, because here see sin x times cos x. This looks kind of familiar, right? Sin 2x if there was another 2 here. So let's bring that 2 forcefully here. I am going to write n equals to 0 to pi by 4, 2 times sin x cos x by 2x plus 1 whole square dx. This becomes sin 2x, and this is same as 2 times x plus 1 square dx, 0 to pi by 4. Now see, if we change this thing 2x, this 2x is really looks odd, because here we had x and this has 2x, and this has pi by 4, this has pi by 2 here. If we could match them, now let's just use t equals to 2x. If we write t equals to 2x, then see, for x equals to 0, t will be 0. But for x equals to pi by 4, t will be pi by 2. So I have dealt the problem with that limit part. And what about the part inside here? So dt equals to 2 times dx. That is dx equals to dt by 2. I'm going to put that here. So now I am changing from x to t. So it will be from 0 to pi by 2. Then sin t goes here, and 2 times x was t by 2. T by 2 plus 1 square, and dx was dt by 2. Now we can simplify this. This will be 0 to pi by 2 times, I need more space here. So sin t, this 2 times 2, 1 by 4 goes here, and for this part I get t plus 2 square by 4. Again this 2 4 cancels. So see, I have something similar. M had x plus 2, this has t plus 2, and dt here I forgot to write. And limit is also same. This is n. So now let's change the variable for n, and let's make it x again. So sin x, x plus 2 square dx. Now we have sin x here, and for m we had cos x here. Cos x is derivative of sin x, and again x plus 2 whole square is here. Something similar thing. We are going to use by parts. So here u will be sin x, u is sin x, and dv equals to x plus 2 to the power minus 2. I'm going to write it this way. So using by parts, we have to write uv. uv will become sin x times, and v is integration of this thing, that is minus x plus 2 to the power minus 1. That I can write here like this. Sorry. Yes. Again minus integration of, we have to differentiate u. vdu has to be here. So differentiation of this is cos x dx. Dx I will write later, and this minus will become plus here. X plus 2 goes here, and that is dx, and limit is of course from 0 to pi by 2. So if I see, m has come back. M was this thing. I'm going to do the limit now. Going to put pi by 2 first. Pi by 2 sine pi by 2 is 1, and here I get pi by 2 plus 2, and for 0 sine 0 is 0, so I have nothing to do with this thing anymore, and here it will be 0 to pi by 2 cos x by x plus 2 times dx. This is m. I am going to put m for this part, and we needed m minus n. So let's switch the sides. Just m minus n will be 1 by pi by 2 plus 2. That if we simplify this thing, 2 goes up and this becomes pi plus 4. Which option matched? Let's just see. This option D matched. 2 by pi plus 4. Option D. I hope you understood this. Thank you for watching. Please like, comment and subscribe.